Using the set builder notation, express the set of all real numbers that cannot be represented as the quotient of two integers. Let us begin. Now, let's try to understand what it means when we say that we have a number that is the quotient of two integers. Any number that is the quotient of two integers, let's say p over q. So p and q are both integers. So here we have p comma q, both belonging to the set of integers. Here q cannot be equals to 0 because we cannot divide by 0, and also p and q do not have any common factors, then this p over q is nothing but a rational number. However, in a case we have to express the set of real numbers that cannot be represented as the quotient of two integers. That means let's consider it to be the set A containing the elements x such that x is real. X is real means x is a real number and x is irrational, because if it cannot be expressed as a quotient of two integers, so that means it must be an irrational number. That means we have the set A containing the elements x which such that x is real and irrational. Or the other way of, there is another way of representing this in the set builder form. So here we have the set A containing the element x such that x belongs to the set of real numbers, but x does not belongs to the set of rational numbers.